A poll reported that 61% of California registered voters approved of allowing two people of the same gender to marry. Among 18 to 39 years old, the approval rating was 78%. 6 in 10 California registered voters say that the Supreme Court's ruling about the constitutionality of California's Proposition A, which is the proposition about same-sex marriage in California, was either very or somewhat important to them. Now, these 6 in 10 are not just 18 to 39 years old. Out of those California registered voters who support same-sex marriage, 75% of them say the ruling is important to them. To make this simple, we're going to let C be the event that California registered voter who supports same-sex marriage. B be the event that California registered voters who say that the Supreme Court's ruling about the constitutionality of Proposition A is very or somewhat important to them. And A be the event that the California registered voters who are 18 to 39 years old. Usually when we solve the problem, we want to simplify this by letting the uppercase A, B, C to be certain events, just like what we just did now. Using these uppercase letters as events, we're going to reread the problem and summarize the information that was given to us. 61% of California registered voters approved of allowing two people of the same gender to marry. This is the percentage, the information for event C. C is the event that the California registered voters who support same-sex marriage. Thus, from this first sentence, we can summarize or rewrite it that P of C equals 0.61. The probability is a number between 0 and 1, so even though this is in percentage, we want to convert it into a decimal number. Among 18 to 39 years old, the approval rating was 78%. It attempted to say that this is the probability of A equal to 0.78, but it is not. There are two events here. Among 18 to 39 years old, meaning given that the group is from 18 to 39 years old, so given the event A, the approval rating is the same as saying that they support same-sex marriage. So this is the same as saying given event A, the probability of B is 0.78. The probability that they support same-sex marriage, which is the probability of the event C, given that this is the group 18 to 39 years old, so given that this is the event A, it is 0.78. The word among is the same as given or if. It is a conditional event. 6 in 10 California registered voters say that the Supreme Court's ruling about the constitutionality of California Prop 8 would either very or somewhat important to them. This is precisely the event B. So we have P of B equals 6 over 10, 6 in 10. Out of those California who support same-sex marriage. So this is the same as saying given or if a random person supports same-sex marriage. So this is the event C. So given C, 75% say the ruling is important to them. 75% of the event B. Thus, this is the probability of B given that they support same-sex marriage, given C. This is 0.75. So what does the event C given A represent? Using the same language, the event after the vertical bar is a given or if or out of. Thus, out of A, the event C. So we would read this as out of those California registered voters who are 18 to 39 years old. The registered voter who supports same-sex marriage. And so, what does the event C given A represent? The event after the vertical bar is the condition, the given, out of, or if. This means out of the event A, which is among the 18 to 39 years old, or out of those who are 18 to 39 years old. C represents the one who supports same-sex marriage or the approval rating. And so C given A represents those who are among 18 to 39 years old, the percentage that they approve same-sex marriage. Similarly, B given C, again, the given event or the if or out of is the event C, which represents the percentage of those who support same-sex marriage. So out of those who support same-sex marriage, the event B, meaning that the percentage of those who say that the ruling is very or important to them. So this means that this is out of those who are supporter, the percentage of those who say the ruling is important to them. P of C given A, we found earlier that it is 0.78, and P, the probability of B given C, we found that this is 0.75, but the question asked for the description of the event. Find the probability of C and B, or the probability of those who support same-sex marriage and those who say that the ruling is very or somewhat important to them. There is an advantage of writing the word problems in symbolic form. In this case, we're looking for the probability of C and B, or simply put, the probability of CB. We saw earlier that this is simply the product of the two events. The probability of C times the probability of B given C. We use the general multiplication rule because we don't know whether the two events are independent or not. Another way of writing the probability of C and B is the probability of B times the probability of C, another event, given the previous event that we use on the left-hand side. Note that regardless of what formula we use, we still need to multiply the probability of the two events that we connect with the word AND. The question is now, which of these two formulas should we use? Well, it depends on what information we have. For example, do we have P of C? Yes, we do. Do we have P of B given C? Yes, we do. Thus, the probability of C times the probability of B given C is 0.61 times the probability of B given C is 0.75. What about the second formula? Yes, we have the probability of B, which is 6 out of 10, 6 in 10, times the probability of C given B. We don't have this. And so the probability of C and B is the probability of C times the probability of B given C, or the other way. we use whichever formula that we have the information for. In this case, we don't have the information for P of C given B, so that is why we're not going to use the second formula. 0.61 times 0.75 is 0.4575. Another question. What is the probability of C or B? Again, armed with the symbolic form, we have a formula for the probability of the two events that join with the word or. This is the probability of the first event plus the probability of the second event minus the probability of the two events. We have the probability of C, which is 0.61. We have the probability of B, which is 6 out of 10. And then we have the probability of CB, which we found up there, which is 0.4575. This is 0.7525. Now, are C and B mutually exclusive? The answer is no, because the probability of C and B is not 0. What about B and C? Are they independent? No. This is the probability of B, which is 0.6, is not the same as the probability of B given C, which is 0.75.